Welcome everyone as we continue our journey with radicals. So today the operation we're looking at is adding and subtracting radicals. We've already looked at simplifying radicals and then multiplying, dividing radicals, and so now we're going to look at adding, subtracting radicals. So first thing, in order to add radicals, you must have like radicals. So the first thing you're going to do is simplify any radicals in the expression. Once you do that, you add or subtract the coefficients of the like radicals and leave the radicals the same. So kind of like terms, you can add 3x plus 2x and get 5x, but you cannot add 3x plus 2y. 3x and 2x are like terms, 3x and 2y are not like terms. So therefore, we're looking for like radicals. So ultimately, 5 root 2 plus 7 root 2, those are like radicals. And based off what we were just saying, you add the coefficients. So this would be 12, keep the radical the same. So that'd be 12 root 2, same idea. We kept that variable the same. Here our variable is technically like square root of 2. We cannot add something like 5 root 2 plus 7 root 5. They're not like radicals. So with that being said, if all the radicals are simplified and there are no like radicals, you cannot add or subtract any further. So for example, square root of 45 plus 4 times the square root of 20. Again, step 1 is to simplify the radicals. So I'm looking for the perfect square that goes into 45, which would be 9. Root 9 times root 5. 9 times 5 is 45. Plus, I have that 4 in front, and 4 is the perfect square that goes into 20. 4 times 5 is 20, so I put them both underneath radicals. I take the square root of 9, which is 3. Leave that as root 5 plus 4. Square root of 4 is 2. I still have my root 5. Now again, we're following PEMDAS. And really we're following PEMDAS the whole time because remember, radicals are really exponents, they're fractional exponents. So we took care of the radical, simplified it. Now we multiply or divide next. So I'm going to multiply 4 times 2, which is 8. So I get 3 root 5 plus 8 root 5. I now can do that addition subtraction. I have like radicals, so I can add these. Remember, you add the coefficients. 3 plus 8 is 5, and then I have root 5. Keep that radical the same. For number 2, I do not have like radicals right now, but I simplify my radical first. Square root of 4 is 4 times, square root of 8 is root 4 times root 2. Square root of 2 cannot be simplified, so I leave that as 4 root 2. I then go square root of 4 is 2, so 5 times 2 root 2 minus 4 root 2. And again, following PEMDAS, I took care of my exponents with the radical. Now I multiply next. So 5 times 2 is 10. And now I have like radicals of root 2. 10 minus 4 is 6, and I'll leave my radical the same, 6 root 2. As I look at number 3, I have 5 root 3 plus 10 root 2. Well, first thing it says to simplify radical. Well, no perfect square goes into 3, no perfect square goes into 2. And so therefore, they're not like radicals. I can't do anything with these. So that's my most simplified answer. All right, as you try numbers 1, 2, and 3, go ahead and try them. For number 1, they already like radicals, so we'd have just add the coefficients, 14 root 3, and we are done. Same with number 2, they're simplified radicals, they are like radicals. 2 minus 8 is negative 6 root 7. And then for number 3, I do not have, they're not simplified and they're not like radicals yet, so I'm going to simplify. 25 is the perfect square that goes into 125, and 25 times 5 is 125. So I have both of those underneath radicals. Minus 2, and then 9 times 5 is 45. I take my radicals, again following PEMDAS, I do exponents before anything else. So 5, and then root square root of 9 is 3. And then again, following PEMDAS, I multiply next. 3 times 5 is 15. 2 times 3 is 6. Now I have that like radicals, root 5, and so I subtract my coefficients, 9, root 5. And the last part of our radicals here is rationalizing the denominator. So it is not proper to have a radical sign in the denominator of a fraction. To get the radical out of the denominator, you must rationalize the denominator, which means you multiply top and bottom by the radical that's in the bottom. So multiply top and bottom by radical in the denominator. All right, so that's how you rationalize. Whatever the radical is in the bottom or the denominator, you multiply the top and bottom of the fraction by whatever that radical was in the denominator. So as we look at number 1 here, I have a radical in the denominator, which again is not properly simplified. So the radical in the bottom is root 5. And so to rationalize that, we multiply the bottom by root 5, and whatever we do a fraction, we have to do to both the top and the bottom. So this is why this works, because if I have, I'll do this off to the side here, if I have the square root of 5 times the square root of 5, that's the same as the square root of 25, which is just 5. Okay, so you're really like squaring that, which is getting rid of the radical. So my top becomes 3 root 5, and my bottom, again, when I do root 5 times root 5, I get root 25, which is just 5. And now I am totally simplified. I do not have any other radicals in the denominator. As we go to the second one, now my radical is root 2. It's okay to have the 3 in the denominator, so I'm going to leave the 3 there. And the only thing I'm multiplying top and bottom by is the square root of 2. So I would have 7 root 2 over, and then I would have 3. And again, you can do it one of 2 ways. You can have it as 3. If you feel more comfortable, you can write it as root 4 to start. 3 times 4 is, or sorry, the square root of 4 is 2. And then you'd end up getting 7 root 2 over 6. If you want to go directly and say root 2 times root 2 is 2, that's fine. And go directly to that answer. You don't have to write that it's root 4. It's up to you, whatever way you feel more comfortable. For number 3, 10 over 7 root 5. Again, the 7 is fine on the denominator, but the root 5 is the problem. I can't have a radical in the denominator, so I'm multiplying the top and bottom by root 5. And that would give me 10 root 5 over, and then again, root 5 times root 5 is root 25, square root of 25 is 5, or we just remember the radicals would cancel out and you'd be left with 7 times 5. 7 times 5 is 35. And then we reduce 10 over 35. Reduces, 5 goes into 10 2 times, 5 goes into 35 7 times. So I'd end up with 2 root 5 over 7. That's the final answer. All right. Number 4, 6 root 5. Remember the way we can write this. This 6 over 5 doesn't reduce, so I can rewrite it as the square root of 6 on the top, square root of 5 on the bottom. Now, neither of these can be simplified any further, so therefore I just have to get that radical out of the denominator, and the way I would do that is by multiply top and bottom by root 5. So I'd end up with square root of 30 over 5. Again, you do want to make sure that no perfect square goes into that radical, and there is no perfect square that divides evenly into 30. So I'd end up with root 30 over 5. Go ahead and try those 4. For number 1, you are going to multiply top and bottom by root 7. So we have 21 root 7 over 7. And then we reduce 21 over 7 to 3. So 21 divided by 7 is 3. I end up with 3 times the square root of 7 as my final answer. All right, for number 2, I want to get rid of that radical or root 11. So multiply top and bottom by root 11. And I end up with 12 root 11 over 11. Nothing else can simplify. 12 over 11 doesn't reduce. For number 3, again, I can't, 5 doesn't go into 49 at all, so I can't reduce that fraction. So I want to rewrite this top and bottom. And the square root of 49 is 7 over root 5. Now again, the problem here is I can't leave a radical in the denominator, so I'm going to now multiply top and bottom by root 5. So my final answer is 7 root 5 over 5. And last but not least, 5 over 7, square root of 5 over 7. Again, I'm going to rewrite it top square root of 5 over square root of 7. And I'm multiplying top and bottom by root 7. So I would multiply 5 and 7 together and get square root of 35 over 7. Final answer. All right, now you know all the operations for radicals.